Hello, everybody. Welcome to the Routing Loop, our weekly show about all things networking, where we talk about connecting your VPCs, connecting your applications, connecting your VPCs back to on-premise. Well, today, we have a session for you related to AWS Cloud WAN and Transit Gateway, so different connectivity option within AWS. For the first time, I think we're coming to you not just on Twitch, but also on LinkedIn AWS Developer. So we'll see how that goes. If folks watching us on LinkedIn, seeing us for the first time, my name is Tom. I'm a solution architect focusing on networking. I've been with AWS for just over 7 years, and I'm one of the co-owners of the show. I have with me Alex and Sid, who are also the co-owners of the show, and I'll let them introduce themselves. Alex, do you want to start where you're coming to us, who you are, what's
Yes,
your role?
yes. Awesome. Yes. Super excited that we are reaching developers. This is the dream of every network engineer, actually, to get to talk to developers. So really excited to be here with you folks today. I'm Alex. I'm a networking specialist solutions architect with AWS. Same as Tom. I work with strategic accounts in AWS. Been here for almost 5 years now. Been in networking for more than three times that, so a long time classical network engineer. Um, I live currently in San Francisco, California, where it's not too sunny. It's pretty windy and very foggy on top of Nob Hill here. So I'm hoping the weather treats all of you better than it treats me today.
I feel you. I'm in San Francisco or close to San Francisco as well, so I see the same doom and gloom weather-wise.
Yeah.
Cool. Sid?
Cool, thanks. Hey everyone, my name is Sid. I'm a principal solutions architect. I don't have the official network specialist tag like Tom and Alex do, but I've been doing a lot with networking over over the last 10 years, which I've been with AWS now, close to 11. It's been a fun ride. It's been fun to see a world where there was no transit gateway, no cloud WAN to where we are, and with generative AI, which we'll talk about today. So that's really cool and fun. Based out of New York, it's nice and sunny today, which is good because it was really gloomy and sad the last couple of days. So a good change. Yeah, looking
So,
forward to chatting with you all developers today.
yeah. So, Sid, we've been trying to pull you into the dark side of being a specialist for a long time, but you're like staying strong in. You're kind of doing the specialist role anyway, but you're also able
Yeah.
to like have your own customers that you're spending time with. So that's cool.
Yeah, it's always fun to be mapped to a customer who's doing a whole bunch of stuff, and it gives me more exposure. And generative AI is one of the things which a lot of customers are doing, so a good exposure there as well. So, yeah.
Okay. So what have you guys got for us today? So I know we're going to talk about networking construct, but we're weaving in some AI automation to build those networking constructs. Uh, Tell us
Yeah,
what you got.
yeah. I'm gonna kick it off. I'm gonna talk about what connectivity options we have, focusing on transit gateway and cloud WAN. We'll see why we need cloud WAN to begin with when we have something so special and great as transit gateway today, and then we'll try to wipe code. Right, that's a new term nowadays. We don't code anymore. We don't write scripts. We wipe code. So we'll see how we can use
Interesting.
generative AI to do some demo and build a network and do some fun stuff.
Cool.
Awesome.
I that's a term that I haven't heard about so far. So that's I'm learning. And I think afterwards, after we go through the cool coding stuff that Sid is gonna show us, we're gonna go back to some foundational concepts in Cloud WAN, such as service insertion and the newly released feature, well, newly, not that new, support for direct connect integration. So we're gonna go back to a bit of routing and a bit of understanding how all these things fit in. And you can absolutely code. Was it vibe coding? How was it?
Yep, vibe
Vibe
coding. You
code.
just like vibe along with it.
Oh,
Alex,
I
you haven't
see.
heard vibe coding?
Hey, no,
That's
I
like the
haven't.
trend. It's been going on for ages. You haven't seen any memes where like two developers are
No,
coding and one is just vibe coding, and then they
no.
build an application that's completely insecure and like they don't know what's going on.
Okay, now let us know in the chat, all of you folks. I see a lot of familiar faces here joining us. So let us know in the chat if you knew about vibe coding already. Am I the only one?
Yeah, you might be, Alex. You might be. All right, Sid, I'll hand off to you. I'll share your screen. You good to go?
Yep. Let me know
All right.
once the screen is up.
Yeah, you're up and running.
Okay, awesome. So I have a sample setup here. I have two AWS regions. I have my on-prem data centers, which already have direct connectivity, and they've all set up the private VIPs and transit VIPs, whatnot, to a direct connect gateway, right? So I'm assuming those who are watching have some familiarity with AWS and understand what direct connect is, direct connect gateway is. Although I think when Alex talks about the Cloud WAN integration, she may recap some of that.
But if you have to sit for like one line, what is direct connect? It's just a fiber link, right, to AWS backbone. Like we can probably try and throw in a single term for every single thing we're explaining for those folks who, it's a lot of terminology. I think once we get used to the terminology, it's easy. But then if you first hear direct connect gateways for the first time, it kind of feels overwhelming. I see that when I'm learning something new outside of AWS, I'm like, what are all these names? So it's nice to, like, when I talk about networking services, I try to avoid even sometimes at the beginning to even talk about our official names because they can get complicated.
I have a way I usually, it's more or less a joke, but not that much of a joke. Everything is a gateway. So at the end of the day, you have transit gateway, you have direct connect gateway. It's all gateways. No, don't have to remember much.
It's like that saying, it's all turtles, right? It's all gateways.
Exactly.
Yeah, it's a gateway. It's a router-ish functionality. It's software defined. It's a cloud magic, like however you wanna interpret it. But here, direct connect, as Tom said, is fiber connectivity between your data centers and AWS via co-location facilities, and then direct connect gateway is a logical entity, a highly available, scalable global router, which you set up BGP peering relationship with. So that's already set up in this scenario, and our goal here is to connect all of this together. You're on-prem to AWS regions together. That's where Transit Gateway comes in. Transit Gateway is a regional entity, so we create one Transit Gateway in every AWS region, and we can connect the transit gateways together through transit gateway peering. That's everything is through the AWS global backbone, highly reliable, highly redundant, scalable. And then you connect your VPCs, attach them to transit gateway. This connectivity is fully managed, and transit gateway by itself is highly available and highly redundant, so you don't have to worry about single points of failures. Next, you connect your direct connect gateway to transit gateway, and that association also is over our AWS backbone. So bunch of APIs to make this connectivity, and now everything is connected together. We also support IPsec VPN termination on transit gateway. And if you have SD-WAN appliances, you can set up transit gateway to SD-WAN peering as well, and connect your branch offices using SD-WAN. For your remote users, you can set up client VPN endpoint in your VPCs, and they can set up remote VPN connectivity to this endpoint and get access to every resource in AWS which that VPC has access to. Right, so that's how the connectivity model works.
And if you folks are interested in more of like how that works for remote access, next week we have actually a session planned for this. For all of you who are familiar with our routing loop page, I'm going to put the link in the chat in just a second. But just go there and see what sessions we're planning. Next week is going to be really fun.
Yeah, a good call out. Yeah, next week is all about the VPN stuff. So let's talk about a scale-based architecture, right? Here we have 4 regions, 4 transit gateways. That transit gateway is a regional entity. And we also create multiple route tables. That's one thing which you can do in transit gateways, create multiple route tables or routing domains, which you can attach individual VPCs into. Now, the process to set all of this up requires you to create attachments, associate them with specific route tables, set up route propagation, You also need to set up cross-region peering, which we saw in the previous slide. Now that's also a bunch of APIs. It's a full mesh, so you'll have to create a whole bunch of peering connections. And we also have a peering route table, which this peerings get associated with. And one main thing to remember here is that you cannot peer individual route tables, right? So you cannot peer a prod route table in region 1 with a prod route table in region 2. It's only a single route table which gets peered, and that's why we create a peering route table. And you write static routes, so there's no dynamic route propagation today, and all the routing you see here, except the VPC route propagation into the route table, is static in nature, including the cross-region routes. You have to write it automatically. You have to write it manually.
So before you jump, because I think I know where you're going with it, but staying on this architecture still, there's a question from Kareem here related to what's the difference between the cross-region peering connection between those transit gateways versus if I've put, my own EC2-based appliances on each side and then created tunnels between the regions myself, right? And I know there's a third-party vendors that kind of build some of these architectures, or at least they used to. Are there any differences? How should we think about it? Kind of what's the benefits? We can have a little quick discussion before we move on.
Yeah. Why don't we, tackle that as I'll tell you the pros of doing this, and I challenge Tom or Alex to tell me the pros of doing it the other way.
I like it. Let's Steelman each approach. Okay.
Yeah, and I obviously took the easy route because this is the better recommended way of doing it. So when you do cross-region peering between transit gateways, it's fully managed. It's over our global backbone. It's zero management. You just need to make one API call, and the peering is set up. I think you guys can correct me, but I think it's like 50 gigabits per second bandwidth. That's on the transit gateway. Our backbone doesn't really impose much limits. So it's scalable. Unlike VPN options, where you have to self-manage those appliances, there are VPN bandwidth limits. There's extra overhead associated with it. So it's basically making a choice between, do you want something which is fully managed, highly available, highly scalable, redundant, high performance, managed by AWS, or do you want to take all of that undifferentiated heavy lifting and do it yourselves? What would you prefer doing? But there are scenarios where setting up VPNs might make sense. I don't know if Alex or Tom, you have any thoughts on why would it make sense?
I have one. And I have one because we're going to answer it with Cloud WAN. But
Yeah.
I think the reason, if we were living in a world where you only had TGW, routing, as you mentioned, is static, right? It's like you have to go into each route table and set up static routes to the prefixes in the other region. And you have to make sure you do this programmatically, because otherwise you're going to end up missing routes if you're doing it manually. So it's not that much of an overhead to do it, but you have to take it into account. And it's not dynamic, right? So if you're coming from the world where you're expecting, well, I just connect these VPCs to the transit gateway and everything works across all regions, that's not what transit gateway does, right? So here you could say, well, I've heard that putting this NFV in my VPCs and peering these VPCs together and putting tunnels between these NFVs is going to allow me to do dynamic routing, right? And the reality is that, sure, it will allow you to do dynamic routing, but again, it's not a fully managed experience. So here's where Cloud WAN is going to be very, very important, and we're going to get to that. I don't know of another reason.
So yeah, I think that's the dynamic routing is one reason, but that's solved by Cloud WAN, right? So and then there's another reason. I think Kareem kind of points to it in his next question. Can you provide more detail of how each route table will get updated over the cross-region peering? So I think the bit that we haven't shown that level of detail, but each peering lands on a single route table. Usually it's a actually another route table that you dedicate to peering. So ultimately, you're going to have to mix your traffic coming in over the peering and going into a particular region. So you can't really maintain that segmentation of a prod route table between regions. So if you had a VPN solution that you manage with EC2 instances, you could set up VPN tunnels and kind of maintain that isolation of a route table across regions between transit gateways. So I would say that probably is the second benefit, but all of those challenges that we heard from customers and are getting solved with the thing with Cloud WAN, which I think Sid is going to show us in a second.
Yep, absolutely. So that's a great question, good timing, because exactly that's where I was going to, right? It's the manageability of static routes, and associated with it is troubleshooting when things are not routing the way it's supposed to, and doing this distributed, because Transit Gate is a distributed service in every region. So you need to reach into that region's control plane to figure out what's going on, is not manageable. And that's why a lot of our customers started looking at these options of creating tunnels with some vendors and partners. So how about getting rid of 4 transit gateways and building a single configuration pane, globally consistent security segmentation, right? And have dynamic routing within these segments and across if needed, right? That's the dream. Also, why don't we add tag-based attachment to segment mapping, so that when we are creating these hundreds and thousands of VPCs, they can automatically get associated with the right segment, and we don't really have to go and manually configure this. And how about policy-based route propagation, where now we can control how traffic is being routed between segments based on policies. So we don't have to go and configure this as you would do on-prem using traditional routing. And how about end-to-end automation for change management? I think we're all very excited for what's coming, and that's AWS Cloud WAN. So let's quickly go through the fundamentals of how Cloud WAN works, and then we can jump into Q Developer CLI and have some hands-on time with this. So fundamentally, Cloud WAN is policy-based, which means when you configure Cloud WAN, you need to write a policy to do it. You start by defining which edge locations you want Cloud WAN to be deployed into. Right? When you do that, behind the scenes, Cloud WAN is going to read your policy, see, okay, you're requesting Cloud WAN to be deployed in 3 regions, and it's going to deploy CNE, or Cloud Network Edge. These are regional endpoints which are managed by AWS on your behalf as a managed service. There is full mesh connectivity between the CNEs with dynamic routing. That's basically, there's eBGP peering going on, and these CNEs are highly available. So these are not single points of failures within the region. Next, we create segments. This is where you define what logical isolation you want. We are creating 3 segments here: production, development, hybrid. Self-explanatory what we'll use these segments for. And within the segment, you have end-to-end global reachability. That being said, we also offer a flag to make things interesting. Isolate attachments equals to true. And if you do that, then we basically isolate all routing, or basically stop all routing within a segment. So if you have multiple VPCs connected to a segment, they will not be able to talk to each other. So once you create your segments, next step is to attach your networks to Cloud WAN. So you can see here, we can attach VPCs, we can create SD-WAN connectivity. We also now support tunnel-less connect, so you no longer have to use GRE tunnels. You can set up native BGP peering between SD-WAN appliances and AWS Cloud WAN. I'm sure more on this will be covered next week and at next week's session. You can also connect transit gateway route tables to AWS Cloud WAN. One important thing here is that you don't, when you peer 2 transit gateways, we mentioned that you cannot peer individual route tables. But when you peer a transit gateway with Cloud WAN, you can actually connect individual route tables. And I'll show you that in a bit. Direct connectivity is now natively supported into Cloud WAN, and Alex is going to talk about that in greater detail. We also support IPsec VPN connectivity. Now, you can see in this diagram, my attachments are connected to Cloud WAN, but they are not associated with any segment. So it's not exchanging routes per se. That's where attachment policy comes in. And we can really do this at scale using tags. So we are saying when the attachment is created, look at the tag value, match it with the Cloud WAN segment, and when there's a match, associated. So we do that, and you can see now my VPCs, SD-WAN connectivity, transit gateway route tables are now associated with the right segments. Now, you might say, hey, I don't want this automation coming and associating my networks to my production segment, because that's something which is very secure, and I want human approval before that. Yes, you can do that. You can put a flag, require attachment acceptance as true, and then you get a optional human approval before these attachments are associated with your segments. All right. Once you do that, you can do routing within a segment, but you still cannot route across segments, right? So prod cannot talk to development, hybrid cannot talk to production or development. There's another policy, segment actions, where you can share segments. So here we are sharing hybrid with development and production. Basically, we are saying hybrid can now talk to development and production segments. Now, you have seen that all we are doing to configure Cloud WAN is write these policies. And as we write these policies, behind the scenes, Cloud WAN is doing the route configuration. It's all dynamic and it's all fully managed.
So the policy said that's a single file, right? Single JSON document where you would specify all of the details that you need regarding what you want to see. So kind of like if people were using Cisco or Juniper in the past, it's like a router configuration, but instead of on a single router, it's magically deployed on your whole global network.
Yeah, exactly. Good analogy. All right, so why don't we jump into Qt Developer CLI? So I don't know if folks listening are aware of what Qt Developer CLI is, so I'll start there. Qt Developer is our AWS service. It's an agent which helps developers be productive. Qt Developer CLI is a CLI-based agent, generative AI-based agent, which lets you perform a whole bunch of tasks. So there's also Model Context Protocol, MCPs, which you probably are aware of. MCP allows LLMs to communicate with different tools. So I am going to start by showing which MCP tools my Qt Developer CLI agent has access to. And to be honest, these tools really make LLMs agents, because they can use these tools to perform a whole bunch of tasks, right? And it's not just generating text. So here you can see I already have a bunch of MCP servers and tools. It has access to AWS CLI, so it can make AWS CLI calls. It has also access to lab analysis MCP server, so I can actually ask it to give me a cost estimate of my infrastructure before deploying it. I also have infrastructure as code tools. Yeah, and I can show an example if you have time, right? So we also have MCP server for CDK and Terraform, so I can ask it to generate CDP and Terraform code, and it not just generates code, it actually goes into the MCP server to do like NAG suppressions, right, and general guidance, and so it's doing like those security checks. It also has a documentation tool, so it can actually in real time go and look into AWS documentation, get the latest documentation, and then perform an action based on that. And this is like really important because these LLMs get trained, they have a cutoff date, and they don't really know what happened after that. And if there's a new enhancement, new change, which happens all the time, it's cloud, right? It's innovating every second. And our documentations keep getting updated. So the LLM needs to have a way to go look into the documentation and get what's latest. It also I have also a diagram tool. So you can ask the LLM to create diagrams for you. And again, if you have time, I'll try to do it. And just for fun, I also put an Airbnb tool in there where you can go and get Airbnb listings, just to show you that it's not all AWS. There's like thousands of other tools which you can access. I'm not going to show that in this demo.
Is that a
Are
case
these
problem?
like,
Go on, Alex.
do you get to like, do you get lists of all of these things you can use? Do you write them yourself? I feel like I'm on super unknown territory here.
Yeah, if you like, no, it's super easy. There's a MCP JSON configuration file which you just need to go and add the MCP client information in there. It's like 4 or 5 JSON lines, and that you're done. You basically go to Google or any search engine and say, give me what are the top latest MCP servers out there. And there's a website which lists thousands of MCP servers, official, unofficial. So official are like from providers like AWS, which you can see a bunch of these are official AWS MCP servers. And there's also from other providers like Terraform and Datadog and like a bunch of AWS partners. And there's like a bunch of unofficial ones which people are creating. For example, this Airbnb one is actually an unofficial MCP server, which somebody just created one, and it gives me Airbnb listings. But the configuration is like very easy.
In case you want to extend Cloud WAN to your Airbnb location.
Yeah, we should try that. Yeah. All right, so I already ran one command here. So it basically I ask you, can you look into my AWS account and give me an overview of my VPC, transit gateway, and Cloud WAN setup, right? Region US East 1, 2, and EU West 1. What it basically did then, it used a tool, use underscore AWS. I just showed you it's a tool, it's an MCP tool, which can execute CLI commands on my behalf. So it started by describing VPCs, got that information, describe transit gateways, got that information, describe transit gateway route tables, get core network information, list attachments. It made an error, then it realized it made an error and then fixed it itself and retried and then got information, made error again, retried. And finally, in around like 5-6 minutes, it gave me my network infrastructure overview. So you can see I have in US East 1, 3 VPCs. In US East 2, 3 VPCs. And EU West 1, 3 VPCs. And you can see it's a production, development, and an inspection VPC. And within transit gateway, again, I have 3 transit gateways, 1 in each region. I have a dev and a prod route table. And in the Cloud WAN setup, I have prod and dev segments, right? And I have presence in 3 regions. It also gives me a summary, right? You have a multi-region setup, you have dedicated inspection VPCs, et cetera, et cetera. So this is great.
That's really cool.
Yeah, I love how it's giving you positive feedback and telling you like how well organized you are.
And I think it would have taken you probably, I don't know how long it would have taken to go and discover this in an environment that you haven't set up yourself or like try to document it. I think that would have been like a 2-day job.
Yeah, and I tried doing it yesterday where I was like, okay, you have all this information, now create diagrams for me. And it just went ahead and created some diagrams as well, nice. Which was very cool. I want to skip that here because it does take some time and we are limited on time. But you can see what it says here. Hey, there are currently no attachments appearing between transit gateway and Cloud WAN. This suggests you have set up Cloud WAN, but you haven't integrated with transit gateways. Super smart. So let's do that. So we can say, can you help me attach my TGW to my Cloud WAN? And you can see I'm like just saying TGW. I'm pretty sure it's going to understand I mean transit gateway. And I did not really give any details here. Now, one best practice when you're using generative AI is you have to be more specific. You should exactly tell which transit gateway, where, how it. I'm like, let's see what it can do. So it's giving me some steps here. Let's create policy tables for transit gateway in 3 regions. After creating policy tables, let's establish peering connections. which is correct, and it's giving me all the CLI commands here. It's not doing it itself yet. It's just giving me the steps. Get the peering IDs, and then create the transit gateway route table attachments, because we can, as I mentioned, we can associate individual route tables to segments. And then let's update the Cloud WAN core network policy. So it's generating a brand new policy for me, because I do need to. And then it's saying, okay, this is how you apply the updated policy, execute the policy change set, verify attachments. It's basically showed me the entire plan. Now I can verify all of this and make sure it's all correct. It looks correct. So let me ask it to do it. Let's see what happens. Can you?
I think the biggest risk,
Interesting.
I think the biggest risk of this, we wouldn't recommend anybody to be using this in production, right? I think that's worth calling out, that it will lie to you through its teeth and make it sound like it's exactly what you're supposed to do. So for like learning, deploying your dev environment, seeing what policies generates, ironing out all the kinks, I think it's excellent. I would be very wary about allowing it to touch anything in my production. Like, that's not what you want to be doing.
Yeah, I think it's great for like sandbox environments.
I mean, Dominic is making a great point. Like, in the end, you can ask it to create Terraform or CloudFormation, and that's it. Like, you don't have to tell it to just go implement it. You could just tell it to, hey, just give me the code and I'll do it, which is absolutely great.
Yeah, I think what I would want it to do is in my dev, deploy it, then run some describe commands to validate everything is as expected. Then maybe I have my own testing on top of that, and then give me the Terraform CloudFormation when that's nice and clean and I know it's working. I think it's going to be with there's no guarantees. You can't be 100% sure it didn't hallucinate something. So I think that's the biggest risk when you run these things, is like for your production environment, and even for your testing, you can't accept that Terraform is going to be perfect. There might be an error in it. So you still need a human kind of reviewing what it's generating.
Yeah. So now it's all right. So it's right. So you can see it's starting to create. So it asks me, do you want me to allow this tool to execute? I'm like, okay, yeah, let's do it. This is a great one. Like, execution failed because it probably made some error in the CLI. But the good thing is that it's going to see the error, and it's going to understand what's wrong and then retry. So it's thinking, and it should pass. So now, okay, so now it completed. So it created the transit gateway policy route table. Now it's going to jump into the next step, which is either it's going to do the transit gateway policy route table for US East 2, or it's going to create the peering. Let's see what it does.
Very cool.
No, it's doing create tags. Wow, it's adding a tag. Right? It's following the best practice. So it created the policy table, and now it's adding tags to it. So yeah, go ahead, Tom.
I wonder if, for the sake of time, you want to jump into Alex's bit and start talking about some of the other options, and then we can come back and see what happened here. Because I think we're seeing where it's going, and it will be good to go back and see where it's provisioned.
I agree. This is going to take some time because it's going to do all the 10 steps in 3 different regions. So it's going to take like 10-15 minutes. So let's let it work while Alex, you take up and talk to us about service insertion and direct connect.
Yeah, awesome. Okay, so to kind of level set on where we are so far for everyone who's joined us maybe a bit later. We've talked about Transit Gateway as a regional routing hub and how it helps you connect thousands of VPCs in a region. We've talked about Transit Gateway peering and what are kind of the downsides for that, for creating global networks on AWS. And we've seen where Cloud WAN comes in to make a difference and to simplify your global networks and to help you do all these nice integrations with Amazon Q, which are great, and sort of streamline connectivity, right? You get attachment-based tag policies, you get global dynamic routing without you having to go and manage static routes. And once we had this available in Cloud WAN, the next use case came from our customers, which we knew it was a use case since customers were using Transit Gateway, which was inspection, right? And the idea of having multiple segments or multiple route tables and saying, well, I don't want them to talk directly between each other, right? I don't want prod to talk to dev, for example. I want to inspect this traffic, and I want to make sure that I'm allowing traffic that should go between these segments using a firewall, deep packet inspection, whatever else I'm doing there in the environment to validate that that is an allowed traffic flow. So here's where Cloud WAN service insertion came to be. So let's do a bit of whiteboarding. Just to we pressed them both at the same time, Tom. That's awesome. I've
On the ball.
put some elements here just to make sure it doesn't take me a long time to draw perfect lines. But this is your Cloud WAN core network, and you can define through that policy that Sid showed your regions, and those are the core network edges. Now, on top of that, you will have your segments, these segments that are on top of your Cloud WAN core network, the under the hood fabric that connects your regions and your VPCs. So we are going to put them here as a logical separation, essentially, on top of the physical, still logical, but your core network edges and where they here under the hood to ensure that your global routing is working.
So many layers that I love, Alex, that you're saying. Yeah, this is the logical on top of logical on top of logical on top of physical.
So many logical things. But this is more or less how your core network looks like. It has a bunch of regions where you have CNEs, and your segments can expand across all regions. They do that by default. You can also go in and say, well, I want a segment to be limited to a specific region or a specific set of regions. We know that this is a really big use case for data residency purposes, so pretty straightforward. Now, on top of this, you would have probably your VPCs, right? And you would have, let's say, prod VPC and a dev VPC. Oh, this is not the color that I wanted for this fellow. Here, just wanted the stroke part. And these are attached to your Cloud WAN core network, and they can talk to each other within the segment. And as we've talked about, you may probably not want prod to talk to dev directly. So this communication right now, not possible. What would you do is to add a firewall level in between those two, right? So you would define service insertion. Now, service insertion on Cloud WAN has a couple of concepts or constructs, just for everyone here to be aligned with them. The first one is the NFG, and you're going to be saying, well, what is the NFG? And I kind of don't get where that acronym stands for, so you lost me. NFG stands for Network Function Group.
I thought it had something to do with Friendly Giant.
Friendly Giant. Oh, that could be. Whatever makes it easier for you to remember it, I guess. Well, the network function group, as its name states, it's intended to help you put together attachments that have a specific function. In our case, the attachments that have a specific function are the attachments that essentially take your traffic through those firewall appliances, or AWS Network Firewall if you use that. So what I'm going to be associating with this network function group is my inspection VPC attachments. We are still looking at a regional deployment, and we're going to see how that translates into a multi-region architecture. But technically, if we look at this and we have no idea how routing works, right? We don't know static routes and we don't want to deal with having all of that overhead, what we can say is we would be talking to Amazon Q, right? Or to a chat assistant would be, hey, I want traffic between prod and dev to go through this inspection thing, right? Because I don't want to allow it to just flow freely. I want to inspect it, right? So let's say that this is VPC 1 and this is VPC 2. And I could have a bunch of VPCs in prod and a bunch of VPCs in dev. And my goal is to say, I'm actually going to write it, inspect traffic between prod and dev. Now, as Sid was mentioning at the beginning, this is essentially or translates into a policy, right? It used to translate into routes in route tables, right? Where you would have to go in and configure static routes to make sure that traffic flows in the right way, right? But now you don't have to deal with that. You don't have to know that. You just have to go and say, well, how am I going to achieve this? And in that policy that Sid showed, you have an action that is called send via. And we're essentially saying when prod talks to dev, send via. What would you say I'm sending it via? Natural language.
Yeah, I would say you're sending it via the network function group.
Perfect. Exactly what I'm doing. Send via network function group. Okay. That's kind of what I want to do, right? Well, let's bring up the policy and let's see how that looks like. Give me 1 second to bring up the other screen. Okay, perfect. You folks can see my screen. Okay, awesome.
Yep. You may want to zoom in, Alex, a little bit.
Yep, let me zoom in here. Is this better?
Yeah, much better. Thanks.
Awesome. Hey, I want this. Okay, this is that Cloud WAN policy we were looking at a bit earlier. And here's where, oh, this is fun. This is where I have segment actions and what I am saying. I'm saying send via segment production when it tries to talk to segment development. And what am I sending it via? Inspection NFG1. This is the name of my network function group. You can define multiple network function groups depending on your needs, but essentially that's what it is. So it's super straightforward. You don't have to know routing at the end of the day. You don't have to know routes and route tables. You can even tell Amazon Q, I bet you can do that, Sid, right? You can tell it, I want traffic between production and development inspected using service insertion. Please do that for me.
Yeah. If we have time, I'll try to run that command and see what it does. And I know it's going to do it.
Awesome. There's also
there's a question from Karim about how this policy is applied. Is it a see any specific things or regional, or is it a global thing?
Yeah, let's go back to the screen share with the whiteboard, because I think that's going to help answer this question. I was mentioning that we've put this in a regional level, right? But let's take this from here. And let's say, well, I have VPC2 and VPC3, but I have them in more regions, right? So let's say I have a bunch of VPCs. I'll give them different names. 3 and 5 and 4 VPC and 6. And let's see. Now you will say, well, to this network function group, I have an attachment. It's a regional attachment as the inspection VPC, and this is kind of my regional boundary, right? So how am I going to do this if we are to do this in a global environment? Well, recommendation is to have inspection VPCs in every single region where you have VPCs that need traffic to be inspected. because otherwise what will happen is you would have traffic flow cross regions for inspection, not an optimal path, and you would add latency. So your deployment would probably look something like this, where you would have a inspection VPC in every region. Now, if you don't, so let's say you have a setup similar to this, let's say region 2, and you don't have one in region 3. Let's say region 3 is not as big of a region for your production workloads. Let's say in region 3 you have, like, I don't know, a limited set of deployments and a limited set of resources that you've deployed, and you want to use the inspection in a different region, right? The one that's probably closest to you, maybe. There's a lot of times when customers are defining their regions as being main regions and small regions. So you may want to go to your nearest region for inspection. And here's where you can define edge overrides. By default, we choose the region where inspection is going to happen. If you don't like that default behavior, you can say, well, I want traffic to be inspected in a specific region that I prefer, that I like, either based on distance or capacity or whatever other criteria you may have. Right?
Probably I would say best practices there, right, is always have an inspection in your region, because you're adding unnecessary latency if you can. And then if you don't have inspection in your region, always use edge overrides. I think our default logic is always going to prefer US East 1, which is Virginia. And, you know, even if you happen to be in Europe or in Australia, so you really want to have, you always want to use edge overrides for any kind of logic. So that would be my like short little tips. And Alex, I think we have 3 more minutes or maybe a few more minutes before we also want to jump in and see what Sid has provisioned through its QCLI.
Yes. There's a super important question, and I think we should address that from Karim Jamali. How do you avoid inspection for traffic, double inspection for traffic between regions? Very, very good. You have a way of specifying in the policy if you want to do double inspection, so you want to inspect traffic both at the source and at the destination, or you want to inspect traffic only at the source, the source or at the destination. This is a setting in the policy. If you folks saw it a bit earlier, it's either single hop or dual hop. So here, when I'm saying send via, I can say single hop, or I can say dual hop. As the name stands, single hop means in just one region, and you can specify which region you want to, again, with edge overrides. And if you want to do dual hop, it means it will happen in both the source and the destination region. And because we've talked about the send via part, send via is segment to segment inspection, but it's not the only action that we allow you to do, or not the only intent we allow you to express. The other one, which is super important, is ingress, egress to and from the internet, right? So centralized egress inspection, where you are sending all this traffic that leaves AWS, right? And this is essentially tied to your default route and default egress to the internet. And there's the other action here, which is send to. So this is segment to segment, and this is essentially egress inspection.
Alex, there's another question. Karim is on the roll.
Yeah.
Which I think is I really want to talk about this as well. About the awareness of what's going on with your firewall layer in the inspection VPC. So maybe that's the final question we take before we jump into seeing what Sid is up to and what is Amazon Q provisioned for us. Do you want to talk about this awareness of, so what's going on that inspection VPC, right? It's Cloud WAN has no clue. That's the bottom line. But Alex, maybe you want to expand.
Yes. So here in my inspection VPC, if we are to go beyond just this high level routing, you're going to probably have a bunch of endpoints. So either network firewall endpoint, one per AZ, or gateway load balancer endpoints if you're using gateway load balancer. Now, you would have routing at the attachments, and you would say probably default route to NFW endpoints or whatever endpoint you're using. And here you're going to say default route to a NAT gateway. And then from the NAT gateway level, you would probably have an IGW that says default route here to IGW. So your routing in the egress VPC is any routing in your centralized egress inspection VPCs. Now, this attachment here comes with a tag to Cloud WAN, and it's associated with the network function group. And Cloud WAN says, oh, this attachment is there. It's available. The attachment state or status does not depend on the health of your firewall appliances, or doesn't know about that. So you do have to make sure you're monitoring. If you're using gateway load balancer, you're monitoring your firewall appliances. If you're using network firewall, you monitor logs in CloudWatch, and you get the visibility into the health of your firewall deployment. And you make the decisions and the policy based on that, right? You can, for example, change your policy and say, hey, in these failure scenarios, in these failure conditions, or in these under certain conditions, I want to move my inspection from happening in this region to another region. Keep in mind that also that is a very disruptive change for a network, right? And it's not a change that you can make, 3 times a day just because you want to adjust to certain conditions in your environment. Regions are and should be treated as independent. You shouldn't create dependencies between regions for inspection, and you shouldn't create dependencies across regions for pure high availability purposes. So yeah, keep in mind, you can monitor the state, you can change your policy based on that state, but it's not something you would probably do often.
Yeah, because especially that Cloud WAN and network firewall, if you deploy it across multiple AZs, they come with an SLA, availability SLA that we provide that gives you, I think, 4 nines for all of the components. So it would be really rare. I don't see many customers who are like, you're trying to extend that 949 availability percentage would add a lot of complexity and potentially create additional risks unnecessarily. So a lot of customers are just happy with with the 4 nines. Get traffic to the VPC. The VPC stuff, it has its own 4 9 SLA, and that's sufficient. All right, I know we have a few minutes left. I'm going to switch to Sid. Sid, are you ready? Do you have
Yes.
anything to show us? Okay, let's see what happened.
All right, so it's a live demo, so it's not supposed to go seamless, right? So so this is what happened. It created the peerings. One failed. And
you may want to zoom in as well, because it's
a
little bit small.
Yeah, let me go full screen. And all right, so it created the peering attachments, and one failed. So I went looking into why it failed, and I realized that my transit gateway ASN was overlapping with the Cloud WAN ASN, which is 101. Rookie mistake. You shouldn't do that, but that was how I had configured it, so it failed. The problem is when it failed, it does not give an error reason here. So I think even Q was not able to debug that. It's only when I tried to create a peering manually, it gave me an error saying your ASNs overlap. So Q did not retry it, so just left it as is. Then it started. You can see it's creating those attachments, but I didn't realize that it's all on pending attachment acceptance. So I did not. I have to manually approve them to get completed. But you can see it's basically going and executing all the steps. So I need to accept all of this. And
I see something there. Diagnosed with Amazon Q. That's Q for console, right?
Yeah, that's Q for console. Yeah.
That's awesome.
So yeah, it's so that's why I had a delay. Hopefully this would have been done if I wouldn't have that mistakes. See, so it's calling the accept attachment request, but I already accepted in the console, so that's why it's giving me an error.
Oh, so it eventually would have done it for you. Interesting.
Yeah, that's cool.
Yeah, looks like it would have done it for me. I'm not sure, or it would have given me a prompt. I've never done this before, this piece before, so. Yeah. But you can see it's like just going through a loop, checking status and understanding what's going on, and oftentimes it goes into like a 60 seconds wait, saying, hey, it looks like it's getting created. I need to wait for it to get created, and it goes on to a 60 minutes wait loop. So it did that a couple of times previously as well. So it says it's seeing some errors and etc. etc. So what I'm gonna do is I'm just gonna
It's actually giving you, it's giving you a suggestion there, number 2. There might be incompatible ASN configuration between the Transit Gateway and Cloud WAN. So
and that's exactly what happened. Yeah. So yeah, hopefully that gives you some idea. I don't know if you have time to try anything else, but
yeah, I think we have to start wrapping up. We only have 4 minutes left, so I don't think we can start anything and complete it properly. So yeah, Sid, Alex, thank you so much for joining. Thanks everybody else for jumping on. You can check out the routing loop page. We do have more sessions coming. I think the next week one, Alex, you're running it. That's going to be remote access and client VPNs. And I think in 2 weeks, we have the one with Cloud WAN and SD-WAN connectivity, direct connect connectivity. So more the hybrid connectivity.
We're going to dive deeper into Direct Connect and Cloud WAN there. We didn't get the chance to do it today, so follow us for more. We're coming back.
Cool. Awesome. Thanks, everybody.
Awesome. Thank you.
Have
a good one, everyone.